It's a bass guitar.
And there's like two major parts to it that were kind of like developed separately, actually. Mike worked on all the strings and like the body and the neck. I kind of built the pad with the kittens on it. That was like, we kind of just like had different things we wanted to do, so we mashed them together. They kind of like Frankenstein instrument. The idea was that you'd get like note information from the strings, like neck and frets and stuff, from up there, and then you'd have like this pad to control, you know, like volume or other parameters of the sound. And like the way it worked out, we tried a lot of different like note on, note off, like logic schemes, but we kind of found the best one that works is that you turn on notes, like when you complete like a fret, like a note comes on, and then you can control the volume down here. When we measure, you can actually tell like when two different strings are pressing on the fret, each combination of strings is a unique voltage.
For example, if we hold down the 4-volt string and the 3-volt string on the same fret, we'll get a voltage around 3.5.
Hello Kitty is actually just like a grid, a 5x5 grid of like digital buttons, digital contacts, and you can see it over here. This is like I got a little toggle grid set up, so you can tell like which ones you're pressing, and you can like press multiple ones at once. And it's built in like so each one of those triggers like a set of coordinates, and like there's this logic in Max that averages like x and y values for them, so you can get like an average point if you're like grabbing like a whole bunch of them at once. Like the volume is here, and then like this direction is like. Pieces of foam with like conductive thread, and like they're actually just enough separated that when you press them, they make a contact.
We just get 5 volts going on to this this white one, and this circuit just it's a bunch of resistors and divides it to just 5, 4, 3, 2, 1, and 0. Because we use fixed resistors, we actually get when you press one of the strings onto one of the frets, you actually get a fixed value. If you use the potentiometer or something, it would be going up and down a little bit. But this works really well. But the next problem we had when we hooked this up to the Deptford box was that we have how many 12 continuous controllers.
Yeah.
So they all created like huge amounts of noise. The ideal range is from 0 to 127, and we were getting noise. The lowest string is at 25 or something, and we were getting noise above 25. So there was, almost about 50. This little circuit down here, it's actually a bunch of low-pass filters, just really basic low-pass filters that go into the Deptford box to eliminate the noise. So with this thing, when none of the frets are being pressed, it's reading a continuous 0, and when we press one of the frets, it's like 25, 0, 50, 0, 76, 0. First, I just did like a regular low-pass filter with a resistor and a capacitor, and then I took I put the end to the ground and read the value. When you press 50, the second string, it was reading 50, and when you let go of it, it was dropping down continuously, like slowly to 0.
Down.
Yeah. Now the circuit is set up so that the string goes, the fret actually goes directly into the continuous input, but there's also another wire that goes from the fret to a resistor, 30K, something like that. That one worked best. Then to the ground, so that the other part draws the noise current, the noise voltage down to the ground, and when one of the strings are being pressed, the actual voltage goes to the continuous controller, and none of the noise goes through it.
I mean, it works really well, like practically, but like some of the noise is just reduced on like 2 or 3 of the frets.
Yeah,
you know? It's
like
like going between 0
almost
and
10
2.
of them are working.
But like all the other ones like straight 0. It's really nice.
This is one of our frets. It's sort of just like oscillating between.
Yeah.
It looks like
Number 6.
0 and 6 or 5 or so.
And when
What happens when you press it? Can we see what?
It's controller 6.
Yeah, it's
2,
the-
3, 4,
No, it's
5.
fret 7.
Oh, fret 7.
Yeah, because it counts.
76.
Yes.
It's basically 4 Thor patches, 1 for each string. The G string is a different one. And
Yeah. And so, yeah. The volume of the drums
Okay.
is the opposite direction of like the delay. You know, delay on this big bassy like sound. When there's no drums, there's just a lot more delay, so it's like fills it out than when the drums are going.
So it really is.
Yeah, because what's great is each like at least each string is monophonic, if not the whole thing. Monophonic things for like the strings. There's you just turn up a little bit of the portamento, and so like they just